This particular presentation was initially entitled AI Drone Infusion on the Edge, Disruptive Safety and Security. Well, that's a mouthful. In truth, it probably would have been better if I just called it something along the lines of, welcome to Big Brother version 2.0. Let me explain. A couple of months ago, I was approached by the CEO of a reasonably well-known technology company, Blue Sky Set Communications. And I was asked if I would be able to assist them with some design and integration difficulties that they're having with the system. The system was initially described to me as being a safety and security system that needed to be used in both private and public applications. They had a need for it to be able to be integrated with existing sensors in the field. They wanted to integrate novel technologies with the system as well. And they also needed to be able to scale it up or down as required so that it could be used in various public and private applications. And then they started explaining the details of the system to me, and as the details started to unfold, I found my eyebrows starting to rise up into my hairline, and as you can see, that in itself is an amazing feat. But I was intrigued. As a technology consultant, I get the opportunity to work with some amazing applications on a daily basis, and with some incredible technologies. And this application was no different. Before I start, I just want to take a look at a quote given by Bruce Schneier, who's a well-known security strategist and technologist. And he made the claim, security is not a product, it's a process. Now, the reason why I've raised this, and why I've made such a long intro into this talk, was for me to try and convey the message across to you that in this particular case, drones are not the solution for a given security application. In this particular case, drones are a component of a system that addresses multiple security and safety applications. Right, so what does it really look like in this particular case? So these are the components, just in a nutshell. The drones, of course, and we'll discuss that in more detail. I just would like to mention that I've used a number of different illustrations to explain how the system works. So these are not the particular drones. The drones are actually in development right now. There's a number of AI-equipped autonomous cameras. There is IoT communication edge servers and gateways for communication of data. There is a converged cloud infrastructure or backend. And then, of course, there is visualization of the data as well, situational awareness and visualization via mobile devices, computing devices of any sort. Now, it's important for you to realize that the system was initially designed so that it could fit into the smarter city concept, the smarter facility concept, and into communities that are in advanced stages of integration with community policing forums and the like. Right? So, just on that point, the legacy devices they were referring to were the multiple CCTV type of cameras that are already installed in a number of public places, in a number of communities and the like. So moving on, yesterday we had a lot to say about artificial intelligence. Now the previous presentation was fantastic, and although I know that thermal imaging has been used in security applications, that's not the driver in this particular case. In this particular case, artificial intelligence is right up front and center. And there's this term, machine vision on the edge, and many people use that term, the edge, and exactly what does it mean? In a nutshell, artificial intelligence is usually implemented through a number of adaptive, self-adapting algorithms. Traditionally, these algorithms used to consume a tremendous amount of time and a tremendous amount of computing power, so it wasn't always possible to implement these in real-time applications. But then, since then, companies such as Movidius, which is an Intel subsidiary, and NVIDIA, which their graphics processing units, have found the densification of computing capabilities allows them to implement and to start integrating artificial intelligence algorithms on the edge meaning in real time, on devices that are acting in the field. In other words, AI is in the device. Doesn't need to push data to a backend for further processing and then wait for the result. Extremely long turnaround process. This gets done in real time. Right, so let's take a look at how AI has been integrated into the security solution that we're talking about, and on the various levels in which AI has been integrated. So what you're looking at over here is a full 360 pan scan camera with one of the Movidius chips built inside, and it provides you with a number of artificially intelligence-driven applications. So let's just take a look at what it does. It actually allows you to do facial recognition. It is able to identify various objects, such as vehicles or such as body. It also, if you take a look at the 2 points over here, it says it classifies events, actions, and situations. So there's some additional algorithms that run in this camera that allows you to identify certain things. And then, of course, in situ facial, body, and object recognition, as I've stated at the bottom then. All right, so let's see what this all means exactly. So one of the things this camera is capable of doing is what they refer to as delineated behavioural analysis. So over there you can see they've demarcated certain areas, right? And these are areas which are supposedly no-go zones. So this could be outside a facility, it could be outside of a building, it could be at a public place of interest, it could be in a community, it could be in your own suburb for that matter. As soon as somebody moves into this area, the algorithm picks it up and an alarm is raised. Alternatively, if you take a look in the back here, there's a gentleman that's at the front of a facility very close to a boomed area, and he's marked as green at that particular point in time. But sometime later, they realize that this gentleman is actually doing a lot of loitering. His behavior is reasonably suspicious. He shouldn't be there, shouldn't be spending so much time doing supposedly nothing in front of a secure facility, such as this. So as soon as an alarm such as these is raised, the data is forwarded onto the back-end system that we spoke of just now. But then another thing happens. The first thing they try and do is they try and capture the facial modeling. Now the facial modeling, if you're making use of the smart camera that we've just spoken of now, gets done within that camera. If you're integrating with existing CCTV cameras, then the data gets pushed via the edge server to the back end, and the artificial intelligence algorithms run there, and then they do a facial recognition match with a database. Right? Now currently that database is integrated into a number of law enforcement data backends. Right? So there are lists and facial models of known criminals, of various types, pedophiles, fugitives and the like. So in essence what happens is that once somebody of a suspicious nature has been identified, the facial recognition model, the facial model has been captured, passed on to the back-end server there, and a match is found. A number of things can happen. If a undesirable was detected as entering into a facility, for example, security could be alerted and they could be activated to help this person off the property. If it was a person in a public place of interest, once again, security could be activated and they could be escorted off the property. If it was in the situation of a riot, for example, right, or an uprising of sorts, then the idea would be that the facial recognition model would be forwarded onto a drone. Before I get to that, the question most people ask me is, well, how effective is this facial recognition? You check me out and go and look it up on the internet if you wish. Just a little over 4 weeks ago, on the 14th of April, a fugitive in China thought that he would be able to hide in a concert where there were 60,000 people present at this concert. This technology, using CCTV cameras and facial recognition, picked this individual out of 60,000 people. and was subsequently arrested. You can check it up on the internet, so you can check my facts if you wish. It's incredibly effective technology. Now what's really interesting is that you've identified somebody that is a potential and desirable. He's entered your neighborhood. He's been tagged as a pedophile. That image is passed onto the drone. What does the drone do? It is kitted with very similar technology. It also has a camera running artificial intelligence algorithms and facial recognition. And what we do is it picks out the individual in the crowd, and if required, implements track and trace algorithms to follow this individual. If you have got an unrest event, behavioral analysis is used to identify who the antagonists are within the crowd. They're imprinted, and if required, can be followed by the drones. And that is the application of the drone in this particular system. Moving on, what you're seeing here is that all of this data is integrated with a geospatial situational awareness system. And it's the same one that we discussed earlier, the gentleman that spoke in the beginning on the UT. And what you're looking over here is just to give an idea of what is achievable. Oopsie, my apologies. What is achievable with 3D modeling. This is actually a 3D model. I know it's hard to believe it's not a photograph, but this is actually a 3D model. It's what can be achieved. But what you're looking at over here is you can see a drone. And it is kitted out with naturally a video camera of sorts. And this is what it usually looks like to most people from the top, right? It's a flat 2D image. But what the geospatial situational awareness does is it takes this image and it wraps it over the contours of the area in which the person of interest is being tracked. Incredible technology this, and available to us and used in South Africa already. And then finally, this is the end system. There's a cloud infrastructure. This is where the data needs to be stored. Now remember, we said that the system needed to be scaled up and down. And there's a new technology on the block. So this is another one of those disruptive technologies that has recently been introduced. Usually, data centers look like this. A lot of this. It's not what you really want. Space, weight, and power requirements for a data center of this nature is massive. So it makes it very difficult to provide a facility with a closed-loop system if you have to integrate this type of data center. SimCloud is a new technology that's come in there, and we're talking about massive savings in rack space. We're talking about up to 60% reduction in volume. We're talking about 60% reduction in your OPEX expenditure. Why? Reduced energy requirements. And then to finish off, just another quote from the late great Steve Jobs, because the people who are crazy enough to think they can change the world are the ones that do.